So in this session, we look at an example problem. So we're given a transfer function between a temperature and a flow. So the temperature is maintained by manipulating this flow rate. The transfer function between these two is given by -5/s plus 0.2. We're told that the initial temperature is at 400 degrees centigrade. Initially, the flow rate is at 5 meter cube per minute. What we are asked here to find the gain of the transfer function, the time constant, and if the flow rate changes to 3 meter cube per minute, what will be the value of temperature when t goes to infinity. Also, it asks you what will be the value of the temperature when time equals 5. And finally, it asks you if there is an alarm at 425 degrees centigrade, whether the alarm will sound or not, and if yes, then at what time the alarm will sound. Okay. Now to solve the problem, first let's take a look at the transfer function. So we have this transfer function we need to express in the form of k over tau s plus 1. Do remember that this term should be 1. So here we have this term to be not to be 1. So to make it to be 1, we need to divide everything by the same term. So that will give us, if we divide -5 by 0.2, we have 25, and 1 over 0.2, 5s plus 1. Okay. Now if you write it down in the standard form, you directly get the value of k and tau by comparing with this equation. So we'll have k to be -25. Okay. So that's one way to do it. Another approach can be when if we have a general transfer function gs, so the gain can be really obtained directly by putting the limit to 0. So for this case, suppose for this case we have a simple transfer function. If we have a complicated transfer function, without writing it in the standard form, you can directly get the gain, which can be obtained as simply putting s equals 0. So for this case, if you do this, you will have s equals 0, -5 over 0.2, also give you -25. So that's an alternative approach for doing this. Okay. Now b again. So what is the value of tau? So you can directly get it as tau to be 5. We are assuming all these values are given in terms of minutes. So 5 minutes the time constant. Okay. Now part C, you see that if the flow rate changes to 3 meter cube per minute. Do remember that flow rate is changed from 5 meter cube per minute to 3 meter cube per minute. Okay. So we have ft to be 3 meter cube per minute. So we'll have this f prime t to be ft minus f naught, which is -2 meter cube per minute. So remember, in the standard formation, we used to write it as m. Okay, so m is -2 here. So we'll have f prime t, we'll simply write it 2 delta naught. Delta naught is the Dirac delta function. This will give us f prime s to be -2 over s. Okay. So that gives you our t prime s to be so if you take the inverse Laplace, we can directly get in terms of what you know km 1 minus -t over tau. Okay, our k is -25, m is -2. So we'll have -25 -2 1 minus e to the -t over 5. So that's our expression for t prime t. Okay. Now it asks you what will be the value of this t at time infinity. Okay. Now in this equation, we know that if you plug in the value of t equals infinity, this term becomes 0. So we'll have the t prime t equals negative 25 times. So we'll have t prime $50. Okay. Now this one way, another approach to get t prime is to use the final value theorem. What says that limit t goes to infinity, t prime t will be limit s goes to 0, s t prime s. Okay. So you can directly use this transfer function there. So what will be s s and s get cancelled. If you put this to be 0, you get the value of 50. Okay. So it says what will be the value of this temperature. So we get t at t infinity will be t at 0 plus t prime at t infinity, which will be 450 degree centigrade. Okay, so it asks you to find the temperature, not in the definitional form, the absolute temperature. Okay, so that's our T. So that's the answer for this part C here. Now part D, it says what is the value of the temperature at t equals 5 minutes. Now what is the significance of this 5 minutes? Here we know that this time constant is 5 minutes. Okay, so we know that the variable reaches 63.2% of the final value at t equals tau. So we know that t 0.632 of t prime at t goes to infinity. So for this case, t at 5 will be 0.632 times the t prime t is 50, so which is 31.6. Okay, so t at t equals 5 will be t0 plus t prime at t equals 5 will be 431.6 degree centigrade. Now the last part here, it says that whether an alarm will sound. Okay, where the alarm is set as 425 degrees centigrade. So we see that the temperature reaches 450. So yes, the alarm will sound. Now what is the time it will take for the alarm to sound? Now we get the expression for t prime t. So we can get the expression for t will be t0 plus t prime t. Okay. So if you want to find out when it will reach 425, so we plug in this to be 425. Our t0 is 400, and we get this to be 50 times 1 minus e to the power negative t over 5. So we need to solve it to find out what will be the value of this t. To do this, we can simply take a look at this equation here. So just simply do the rearrangement to get 1 minus e to the power negative t over 5 will be 425 minus 400, that's 25 divided by 50. So that's our 0.5, giving the value of this e to the power negative t over 5 to be 0.5, and upon solution you will get negative t over 5 to be 0.5. This gives you negative 0.69, gives t to the 3.5. So the alarm will sound after 3.5 minutes. Okay. It's important that you follow the step-by-step procedure and do all the steps, although the transfer function may be simple.